It's unique design and engineering. You don't pull that stuff off the shelf.
No.
No human has traveled farther into space than the Voyager space probes. For over 4 decades, Voyager 1 has defied all expectations. Originally designed for a 5-year mission, it has surpassed every estimate and ventured far beyond its intended path. We've made so many discoveries and created countless memories with this spacecraft. And now, something extraordinary has happened.
For about the last 24 years, you know it well, you love it, you have the cupola above us.
Sure, there it is.
And so that was the first step in understanding humans off the planet.
Voyager 1 has detected unknown objects passing by in space, and it has changed everything. Voyager has made incredible discoveries about the formation of stars and other celestial bodies, helping us better understand outer space. These latest revelations have sent shockwaves through the scientific community, challenging our understanding of the universe. But how did Voyager 1 even reach this point? Let's take a look at this video. Since its launch in September of 1977, Voyager has made history becoming the longest-running space probe. Now, Voyager 1 was launched after Voyager 2, but because of a faster route, it exited the asteroid belt earlier than its twin, having overtaken Voyager 2 on December 15th of 1977. It began its Jovian imaging mission in April of 1978, when it was about 165 million miles from the planet. This was the first time we received in-depth information from a planet within our solar system. In 1979, Voyager 1 was taking a picture every 96 seconds for a span of 100 hours to generate a color time-lapse movie to depict 10 rotations of Jupiter.
This is tuned to observe galaxies being born at the beginning of time.
The Voyager 1 spacecraft also crossed into the Jovian moon system and discovered a thin ring circling Jupiter. Voyager 1 encountered several of Jupiter's moons, including Amalthea, Io, Europa, Ganymede, and Callisto, returning spectacular photos of their terrains and opening up completely new worlds for planetary scientists. However, Voyager had much more to offer, and we would soon make some incredible discoveries once Voyager 1 left our solar system. In August of 2012, after 3 decades, Voyager 1 officially crossed the heliopause, marking its entry into interstellar space. This was no easy feat. As the spacecraft moved farther away from the sun, its power source dwindled. The sunlight that once fueled its instruments and systems became scarce. To generate electricity, Voyager 1 relies on 3 radioisotope thermoelectric generators, RTGs, that convert the heat from decaying plutonium into power. But as the heat output of the RTGs decreased, available power diminished, impacting the spacecraft's operations. Non-essential systems and instruments were deactivated or put into a dormant state to conserve energy.
All right, you can look deep inside. It's tuned for infrared to make that happen, and it's got a huge collecting area.
But power isn't the only challenge Voyager 1 faces. Communication becomes increasingly difficult as it ventures deeper into interstellar space. The vast distance between Voyager 1 and Earth results in weak signal strength. It takes over 21 hours for signals to travel from the spacecraft to us. Background noise interferes, making data transmission and reception a substantial hurdle. As if that weren't enough, temperature becomes a factor too. In the heliosphere, Voyager 1 experienced higher temperatures due to its proximity to the sun. But in interstellar space, it encounters extreme cold. These temperature variations put stress on the spacecraft's materials, electronic components, and systems. The power output of the RTGs further declines, exacerbating the already existing power challenges. Let's not forget about interstellar dust. Though minuscule, these dust particles pose a risk to Voyager 1.
James Webb Space Telescope is specially tuned to observe infrared light.
Over time, they collide with the spacecraft's surfaces, causing wear and tear. Dust accumulation on optics and sensors interferes with their functionality, degrading the quality of the collected data. Despite all these obstacles, Voyager 1 soldiered on, collecting valuable information. The data it transmitted back to Earth was vital for our understanding of the cosmos. But then, amidst the stream of information, something extraordinary occurred. Voyager 1 detected an anomaly. Signals revealed the presence of 300 unknown objects, a revelation that left scientists perplexed. These mysterious entities emerging from the depths of interstellar space challenged everything we thought we knew. Are they remnants of ancient celestial bodies, drifting relics from distant star systems? Or do they signify the existence of previously unknown phenomena? uncharted realms waiting to be unraveled. The data transmitted by Voyager 1 was scrambled, making it difficult to decipher. Countless questions emerged, but answers were elusive. However, amidst the confusion, one thing became clear. Voyager 1 itself remained remarkably unaffected. Its communication link with Earth remained intact and none of its fault protection systems were triggered. This meant that the spacecraft wasn't under attack. So what was causing the scrambled data? Scientists at NASA embarked on a meticulous analysis of various factors. They considered the impact of cosmic radiation on electronic components. But as Voyager 1 ventured further away from Earth, it faced numerous challenges.
I watch you fly by, and the faster you go, the slower time ticks for you. Okay?
Temperature fluctuations threatened the stability of its sensitive instruments, and telemetry anomalies puzzled scientists and engineers. Weeks turned into months as a dedicated team of researchers tirelessly worked to unravel the mysteries that plagued Voyager 1. They employed advanced data processing techniques, developed innovative algorithms, and simulated various scenarios. Their goal? To isolate the root cause of the unusual telemetry anomalies. Finally, their efforts paid off. They discovered that the source of the problem lay within Voyager 1's Attitude Articulation and Control System, the AACS. Specifically, a dormant onboard computer. Somehow this computer had started utilizing resources despite being non-functional for years, corrupting the transmitted data. But the rest of the spacecraft remained operational, diligently collecting data from the depths of space. The engineers quickly devised a solution. They sent a command to Voyager 1 instructing the AACS system to switch to the correct computer for transmitting telemetry data.
On my priority list, I have a bias because I study exoplanets and I have so many burning questions that I want answered, so I really want to look at those first.
A seemingly simple fix, but one that required extreme coordination and patience due to the significant time delay caused by the vast distance between Earth and Voyager 1. Now, here's the fascinating part. To even troubleshoot the issue, the engineers had to delve into manuals from the 1970s. Decades-old knowledge combined with present-day technology became the key to restoring Voyager 1's communication stream. Their expertise and dedication proved vital in overcoming the challenges of space exploration. But why did Voyager 1 deviate in the first place? Engineers suspect a faulty command triggered the utilization of the non-operational computer, highlighting an underlying issue within the spacecraft's intricate computer network. However, mission managers remain cautiously optimistic, assuring us that this incident doesn't pose a significant threat to Voyager 1's long-term well-being.
It keeps doing its orbit around the Earth like nothing's happening, while this spacecraft is still out there.
Voyager 1 continued its historic journey, reaching a monumental milestone, the heliopause. This boundary marks the outer reaches of our solar system, where the sun's solar wind meets the interstellar medium, located a staggering 11 billion miles away from the sun. The heliopause is an awe-inspiring frontier. Beyond the heliopause lies uncharted territory. As Voyager 1 crossed this boundary, it experienced a drop in temperature of solar wind particles and a change in the direction of the magnetic field. It also encountered an increase in the presence of galactic cosmic rays, high-end energy particles from distant cosmic sources. Voyager 1's successful voyage into the heliopause provided humanity with an initial glimpse into the wonders of deep space. But it didn't stop there. Voyager 2 followed in its predecessor's footsteps, venturing into interstellar space in November of 2018. This historic achievement marked a new chapter in our understanding of the boundary between our sun's realm and the vast interstellar medium. As Voyager 2 crossed the heliopause, it made intriguing discoveries. It detected a decrease in the intensity of low-energy ions, a result of leaving the influence of the sun's direct emissions. Simultaneously, it observed an increase in the intensity of cosmic rays originating from distant cosmic sources. These findings provided scientists with valuable insights into the complex dynamics occurring at the interface of our solar system and the interstellar medium.
How you remember to pronounce magnetosphere correctly is think of magneto and then put a sphere on the end of it.
Good, there you go.
Nice.
All right, so this is on the other side of the moon, right?
No, it's directly behind the Earth in line from the Earth to the Sun.
But what lies beyond the heliopause? What mysteries await our exploration? Enter the Interstellar Probe, an ambitious NASA space probe concept that aims to take us further than ever before. Proposed in 2018 by NASA's Applied Physics Laboratory, This groundbreaking mission envisions launching the probe between 2036 and 2041, embarking on a journey that will span several decades and cover hundreds of astronomical units away from Earth. The interstellar probe's mission is to gather comprehensive measurements and insights into the conditions prevailing throughout the heliosphere and the heliopause. Through the utilization of advanced technology, it represents a significant leap forward in interstellar exploration. This pioneering mission will not only expand our understanding, but also pave the way for future ambitious endeavors. Now, you might be wondering, could the interstellar probe truly bring us more information than we already have? The answer lies in the hands of time and the dedication of scientists and engineers. But what are your thoughts on the incredible and stunning discoveries made by Voyager 1? And what can we expect from future space probes? Do you think we'll make some new discoveries, such as the existence of life in outer space? Do let us know in the comments below. That's it for today's video. We hope you enjoyed watching this one. Thank you for your time.